Hello everyone, welcome to yet another video of the series where we are trying to implement the ideas laid down in the instructed paper. So in this notebook, we would be uh, implementing code which would help us to bring the ideas from the instructed paper to life. And this notebook is the first in the series of such notebooks. Uh, so we have two agendas here. First is to have a framework which can generate a caption for an input image and identify what type of image that is, whether it is a photograph, painting, etc. In the original instructed it paper, they had used the blip 2 model. They had used the blip 2 model for generating the captions, but since it is quite a heavy model and for my hardware, that is the hardware provided by Kaggle, it was a bit heavy. So I have used some other models, two different models to be specific, to save some RAM and to accommodate everything in the limited hardware. So now let us import the required libraries. Basically, we will be using the transformers library and the auto model classes to initialize our model and to to uh, work with the models. Now, in order to generate the caption, we would be using a multi-model model from Microsoft, which is known as the Git-based Coco. So it is a multi-model model generated uh, using the Coco dataset, and more information about the model can be found in the model card here. So basically, at a very high level, this model now would help us to generate a caption of a given image. First, we will use the auto classes to initialize our model. So we'll provide the name of the model that we are going to use, and then we will initialize it. After it is initializes, so we will feed a image onto it, and for our input image, we will take an image from the uh, Pexels website. So it goes by the name pexels.com. Now what we will do, we will use a download URL function. It is a function provided by the FastAI library. So FastAI library is a deep learning library. It is a quite famous and useful library, and it not only provides you with APIs for training your deep learning models, but also provides some convenience functions which you can use in your project. So we will use one such function known as download URL. What it does is that it takes in a image URL and downloads it and provides you the path of the downloaded image. That's it. Then here is our image. It looks like this. So we will use this to generate a caption for the same. In order to generate the caption, we will use the processor object which we had created in the previous section. So going up, this is the processor object which is created using the auto classes, basically the auto processor class from the transformers library, and we will be feeding in our image, and we will ask it to uh, convert those into numbers, into tensors. Then those tensors will be fed to the model object, and then it would generate a caption for us. So this is the caption that it had come up with. Now the next thing is to identify what type of image it is. So if we go back to the instructed it paper, so they do similar kind of stuff. They generate an image, and then they also generate what kind of image it is it is photograph or painting or whatever. Do the same here, and for identifying the kind of photo, we would be using the flip uh, visual question answer base model. Like always, The details, more details about the model can be found in the model page, which is here. And we would be asking it a simple question that is this a photo, painting, or another kind of art? So that is the token that we are going to, or text that we are going to feed into the model. And like always, we will be using the transformers library, basically the blip processor and blip for question answering classes, uh, which then we would be uh, feeding our text, our prompt to this particular object and get a answer from that. So how we do that? We create our question, store it in a variable, and then we feed our question and our image into the processor object and ask it to return tensors, which are numbers, which which is the way the models recognize the images and the questions. So this would be a image and question pair, and all the inputs would be fed into the model object. And after the inference happens, we would need the predictions to be converted back into text, which would be done by the processor to decode a function. And this is the answer that we get, that it is a photo. We are going to save everything into a file, into a JSON file, because this would be the JSON file that we are going to use next in our pipeline, in the next notebook basically. And for convenience, I have created a couple of functions. It is just combining all the above steps from the previous sections into nice little functions, which you can use and get the same results. This was all for this notebook, for this video, and in the next video we will see how we are going to use this generated uh, captions.